So in this video, we're going to deal with some of the trickier translations. Some of these are made tricky because they use English operators, what are essentially English operators, that we don't have symbols for, like only, if, and unless. And others are tricky because they look a lot like propositions that we do translate straightforwardly with the symbols we have, but which require slightly different treatments. So there's 5 that I'm going to focus on. We're going to first talk about propositions of the form P if Q. Then we'll talk about propositions of the form P only if Q. And then P unless Q, and either P or Q. And finally, neither P nor Q. All right, so we've already noted there are many English operators besides the 5 for which we have dedicated symbols in propositional logic. Most of these, like because and in spite of and during, are not truth functional and are therefore beyond the scope of propositional logic. But others, like unless and only if, can be translated into sentences using just our 5 operators. So in this video, we address some of these trickier translations. So P if Q. We've already learned how to translate propositions of the form if P, then Q, using the arrow. But in English, we also sometimes just say P if Q, as in, the cat will scratch you if you keep teasing it. If you think about this one, you can probably see how to translate it using the arrow, and you should stop the video and try to do this before proceeding. This sentence is logically equivalent to, if you keep teasing the cat, it will scratch you. So it's not hard to see that all we're really doing is making sure the if sticks with this clause and running it to the front of the proposition. The cat will scratch you if you keep teasing it. Oh, if you keep teasing it, it will scratch you. Hence, English sentences of the form P if Q are really just rearranged versions of if Q, then P. Of course, this applies to more complex sentences with this basic form. For example, the cat will scratch and bite you if you tease it, but don't feed it. I won't give the solution to this, but you should stop and symbolize it yourself as well. Then there's P only if Q. Now, in English, we often say P only if Q, as in, I will kiss you only if you brush your teeth. As with if propositions, the same only if proposition can be expressed differently. For example, the following are both logically equivalent to the above. Only if you brush your teeth will I kiss you. I will only kiss you if you brush your teeth. Now, in order to produce the correct translation of P only if Q, the first thing we must get clear on is that it is not logically equivalent to P if and only if Q. In other words, we do not translate it using the biconditional, the double arrow. So, given that understanding, how would you go about translating the sentence? Try it. I will kiss you only if you brush your teeth. Before we get to the right answer, consider the following dialogue. Butch, I need a kiss. Barb, only if you brush your teeth. Butch, later. Okay, I'm all minty fresh. Where's my kiss? Barb, no. Butch, what? You said you would give me a kiss if I brush my teeth. Barb, No, I did not. I said only if. I have other conditions as well. I also need you to give me a foot massage, make dinner, and take out the garbage. Well, Barb may be cruel, but Butch is not actually exposed to her as a liar. When we say P only if Q, we're not saying if Q then P. Rather, we're saying if not Q, then not P. When Barb says, I will kiss you only if you brush your teeth, she means if you do not brush your teeth, I will not kiss you. Hence, one perfectly correct translation of I will kiss you only if you brush your teeth is if not B, then not K. If not brush, then not kiss. No brush, no kiss. However, a simpler and equally correct translation is if K, then B. If kiss, then brush. You'll soon be able to prove that these two propositions are logically equivalent. For now, to see that if K, then B is also correct, suppose that Barb speaks truly when she says, I will kiss you only if you brush your teeth. So, if Barb does kiss Butch, what may you immediately infer? Right, Butch brushed his teeth. Well, you've been speaking English for a long time, so it may be pretty surprising, even a little annoying, for you to be told at this late stage that P only if Q just means if P then Q. But it's important to remember that a lot of our ordinary intuitions about meaning are based on context. In that context, it was probably quite reasonable for Butch to think that brushing his teeth would be sufficient to give him a kiss. If Barb wasn't lying, maybe she was being a bit deceptive. In logic, however, the meanings we adopt are independent of context. Unless is a very common English operator with a pretty straightforward translation as well. Suppose you state one of these logically equivalent propositions. You will fail unless you study. Unless you study, you will fail. This can be translated into the following conditional. If you don't study, then you will fail. Just as with only if, sometimes people seem to use the word unless to indicate something a little stronger. The proposition, you will fail unless you study, might also be intended to suggest that if you do study, you will not fail. On this strong interpretation, you would translate unless as the biconditional, not as if and only if F. However, we will not use this interpretation. In general, we always adopt the weakest interpretation defensible. And this is because we can always create the stronger interpretation as a conjunction of the weaker interpretation with other propositions. Well, if you're having a bad day, it can be hard to remember that P unless Q means if not P, then Q. What's funny is that if you got the capital letters reversed and wrote if not Q, then P, that would also be correct. These are logically equivalent expressions. As long as the antecedent, which is, as you remember, the first part of the conditional, is negated, and the consequent, which is the second part of the conditional, is not negated, you're going to be okay. However, it's also interesting and quite helpful to note that if not P, then Q is logically equivalent to simply P or Q. Again, this is something that you'll be able to prove quite soon, but to get an intuitive sense for it, just think about it like this. Suppose if not P, then Q is true. Now, obviously, P itself is either true or it is false. Well, what this means is that either P is true or P is false. In other words, not P is true, which implies Q, right? So either P is true or P is false, in which case Q must be true. Hence, P or not P, which implies Q, P or Q. Of course, you don't need to remember this reasoning. You can simply remember that P unless Q is logically equivalent to P or Q. Helps to remember the reasoning, though, because it's such a unintuitive equivalence that you might start questioning yourself. Well, in English, we seem to use the word or in two different ways. There's an inclusive sense and an exclusive sense. As we will make clear in the next section, our disjunction is inclusive. The wedge, the symbol for or, is what we call the inclusive or. So this entails that the proposition P or Q is true even when both P and Q are true. This is something we'll be exploring in more detail in the next module. So for example, if I say Venus or Serena will make it to the finals, this statement will be understood to be true even if both Venus and Serena make it to the finals. If, on the other hand, I say Venus or Serena will win the tournament, it will be very clear to you, if you know anything about tennis, that Venus and Serena cannot both win. So it is tempting to say that this is a different exclusive sense of the word or. Interestingly, this does not actually follow. It is true that a singles tennis tournament can only have one winner, but this is just a fact about tournaments, not a fact about the meaning of the word or. In other words, as in the previous examples, we can still work perfectly well with the weaker interpretation. In this case, Serena or Venus will win the tournament would be true even if they both won. It's just that in the real world of singles, that never happens. Sometimes, however, we preface P or Q with the word either. And it is true that in English, when we emphatically say either P or Q, we usually mean to exclude the possibility that P and Q are both true. That is why we sometimes call this the exclusive or. The reason we do not have a dedicated operator for the exclusive sense of or is that we just don't need one. If someone emphatically says, I'm going to order either the lemon souffle or the cream puff for dessert, it would be pretty surprising to us if they ordered both. We might even say they lied. If we really want to capture this exclusive use logically, we would simply translate it as follows. L or C, lemon souffle or cream puff, and not L and C, right? So when we say exclusively, I'm going to order either the lemon souffle or the cream puff, we're saying I'm going to order either the lemon souffle or the cream puff, that's the inclusive or, and by the way, not both. So in English, I'm going to order the lemon souffle or the cream puff, but not both. This is important. When doing translation problems on worksheets and tests, you will often encounter the word either, because it is a very helpful way of disambiguating complicated sentences. However, unless specifically instructed otherwise, you will not be required to translate an English sentence of the form either P or Q in its exclusive sense. So you don't ever have to worry about that unless you're specifically told to attend to it. In other words, even if a sentence seems to be very emphatic about the use of the word either, you may simply translate it in the form P or Q. Finally, in English, we often construct propositions of the form neither P nor Q. For example, neither doctors nor politicians really want to make healthcare affordable. Neither nor statements are easy to translate as long as you really think about what is being said. If the above statement is true, do doctors want healthcare to be more affordable? Do politicians? Obviously, the answer to each question is no. Hence, your translation must be logically equivalent to the proposition that doctors do not want healthcare to be more affordable, and also politicians do not want healthcare to be more affordable. In other words, propositions of the form neither P nor Q are simply translated as not P and not Q. The only reason this is counterintuitive to some is that the word nor seems to demand the use of or. So people will often write incorrectly, not P or Q. Right? So just to emphasize, this is correct. This is incorrect. The truth of this proposition does not depend on both P and Q being false. It only requires one of them to be. Well, as you might expect, there is a logically equivalent expression using disjunction rather than conjunction. As we just said, not P and not Q is not logically equivalent to not P or not Q. However, it is logically equivalent to not P or Q. It is not the case that P or Q. And pay particular attention to how I've said this. Don't just say, as I said in the beginning, not P or Q. When you see these parentheses, you can see that what's happening is that the entire formula P or Q is being negated. So this says it is not, and then the phrase, the case there is a very nice one to use. It is not the case that P or Q. To see this, just think what it means to deny the entire proposition P or Q. If someone asserts P or Q, she is asserting that P is true or Q is true. Hence, if you flatly deny this, if you negate it, you are saying that is not the case. It is not the case that P is true or Q is true. In other words, they are both false. Okay, here's a few study questions. You'll be given a proposition to translate. Stop the video when you see it. Start it when you're ready to see the solution.